Hey guys, Coach Sharp back here. Um, just got done with my Zoom meeting. Had about a dozen of y'all popping in and out. Thanks to those that attended. Definitely going to try to do another one next week. I know it's spring break, so just pop in if you can. I'm not going to have y'all assigned any work next week, so y'all can just pop in if you can. I might do another one Friday as well. But in the meantime, let's get back to our work. So I am going to do the second page off of the 200-page packet, which is 6 more problems. So problems 7 through 12. So with that, let's get it started. All right. Number 7. In the diagram below, triangle ABC, line segment BC is extended out to point D. The measure of angle A is x squared minus 6x. The measure of angle B is 2x minus 3. And the measure of angle ACD is 9x plus 27. What is the value of x? So again, something we didn't explicitly do, but this is the exterior angle theorem. And we have seen a little bit before. So again, this is the idea that if you look at angle C on the inside right here, okay? Angle C on the inside and then ACD, which is on the outside, they form a straight line. It's a linear pair, so those add up to 180 degrees, okay? Inside the triangle, angle A, angle B, and angle C inside the triangle also add up to 180 degrees, okay? So this is really what you got. I'm actually going to show it in a way I don't think I have before. You've got A plus B plus C is equal to 180 degrees, and then C plus ACD equals 180 degrees. So I have that written out. So since these are both set equal to 180 degrees, we could set them equal to each other. So I've got A plus B plus C equals C plus ACD. Okay? So what do these have in common? Well, they both have C in common. Technically, if I'm showing the math correctly, I would subtract C from both sides. They would cancel out. So that leaves me A plus B equals angle ACD. So if we look at it, angle A and angle B have to add up to this obtuse angle on the outside, angle C. So we know what A is and we know what B is, and we know what ACD is. So we can go ahead and set up our equation. Okay? So A is x squared minus 6x. So x squared minus 6x plus B, which is 2x minus 3, is equal to ACD, which is 9x plus 27. All right. So first thing we're going to do, since this is plus, I don't have to distribute a negative sign. So it's x squared minus 6x plus 2x minus 3. So I've got x squared, negative 6 plus 2 is negative 4x. Still got the minus 3 equals 9x plus 27. Okay, I don't think we've seen a lot of problems like this, so here's our problem now. Okay, y'all might have seen something like this last year in Algebra 1. I have an x squared, so when I see x squared, usually it means I want to try to set up a quadratic. So I need to move everything to one side and have 0 on the other side, okay? So I'm going to move both of these over here, okay? Those are going to cancel out. Those are going to cancel out. Now I'm going to combine all that. So I got x squared. Negative 4x minus 9 more x is negative 13x. Then negative 3 minus 27 is negative 30. So that gives me this. X squared minus 13x minus 30 equals 0. So being quadratic, got to factor it. Okay? So I need two numbers that multiply to give me 30 that add or subtract to give me 13. That's usually how I start on. I don't think I showed a lot of quadratics to y'all this year, but when I'm first looking at it, I ignore the signs to start with. Okay? What can I multiply to get 30 that I can add or subtract to give me 13? Well, the problem here is there's two pairs. 10 times 3 is 30, which if I add that, it gives me 13. But also 15 times 2 is 30, and then 15 minus 2 is negative 13. So there's two number pairs now. Okay, you get that occasionally. So this is where the signs are very key. Okay, 30 is negative. So I know that I'm multiplying two numbers with opposite signs. One's got to be positive, one's got to be negative. Okay, so what that also tells me is, since this is negative, I'm going to be subtracting two numbers to get this. Okay, so I know that's going to be 15 and 2 because I got to do 15 minus 2. Okay, but now that this is negative, it's actually negative 13. So what's going to give me negative 13? 15 minus 2 or 2 minus 15? It's 2 minus 15. So I've now factored it. And if you don't remember from here, this is the zero product property now that we have to imply. Again, I've taught it to my Algebra 1 kids this year. If I can cancel out what's in this parentheses and make it 0, it doesn't matter what's over here. 0 times that is going to be 0. Same is true here. So what's going to cancel out? Positive 2. Negative 2. It's going to cancel out negative 15. Positive 15. Okay? So those are the two numbers that I got. All right? So you see I got two answers, right? Now if I look, there's not any answer choices that have two answers. It's just one. You got 10, 2, 3, and 15, right? So our answer is number 4, 15. It's positive 15, okay? Because we got negative 2, right? We can't just take off the sign and say 2 and answer that one, okay? Because, again, you got to remember what happens if we actually plug this back in. Let's actually plug in negative 2, okay? Where negative 2 is going to give me a problem is angle B. Okay? If I plug in negative 2 there, I've got negative 2 times 2, which is negative 4, minus 3, which gives me a measure of negative 7. Okay, and it doesn't matter whether I'm measuring length. This should actually be degrees since it's the measure of an angle. Whether it's length or degrees, I cannot have a negative number be a measure. So that is why 2 does not work. Negative 2 does not work. And it has to be 15, which is answer choice 4. So again, going back to first 6 problems yesterday, you had a lot of answer choice 4s, a lot of answer choice Ds. All right, give me a second to erase all this while I'm trying to hold the camera on question 8. In rhombus ABCD, the diagonals AC and BD intersect at point E. If AE is 5 and BE is 12, what is the length of AB? So, again, this is something we didn't explicitly talk about. A rhombus is just like a parallelogram. Has all the same properties of a parallelogram, except all 4 of the outside sides are equal length. Okay? So we got that. My diagonals are I just realized it's not on paper. I said we got that. Give me just a second. All right, so A, B, C, D. Okay? Let me actually show it. I just realized it still wasn't on there. All right. And E is here in the middle. All right, so it says AE is 5, BE is 12. Well, you're going to say, well, Coach Sharf, how can I solve this? Well, the last thing about the rhombus is, the extra thing is, when the diagonals intersect, they're actually going to form right angles. Okay? They're perpendicular. So if I'm looking at, I got a triangle with a length of 5, with a leg of 5 and a leg of 12. So I'm looking for AB, okay? Which if you actually kind of turn it, you can clearly see is my hypotenuse. So I can just use the Pythagorean formula. 5 squared plus 12 squared equals, I'll say question mark squared, which is 25 plus 144. Equals question mark squared. Add that as 169. And then I square root both sides. Oops, tries one on square root both sides. So my question mark is 13, which is answer choice 3, or again C if you want. So again, a lot of 3s and 4s, C's and D's, however you want to say it so far. Okay. And again, I sent out the whole thing. I didn't cut off the answers. If y'all actually go look, again, starting at page 120, the answers are there. But again, I need more than the answers. I need the work. That's why I'm posting the videos. Again, it wouldn't really do me much good if I just sent y'all these problems and sent y'all the answers. Y'all still have to see the work, understand the work, show the work, so you know what you can show me you know what you're doing. All right. Scalene triangle ABC is similar to triangle DEF. Which statement is false? So before we look at the statements, we gotta say this, okay? Scalene triangle is ABC is similar to DEF. They're both scalene, so none of the angles are the same in one triangle, but you might have the same you're gonna still, since they're similar shapes, you're still gonna have, pardon the background noise if y'all can hear that. Let me draw it out. All right, let's draw this out. A, B, C, D, E, F. All right, 2 scalene triangles, right? So none of the angles in one triangle are the same. A is not the same as B is not the same as C is not the same as A. Okay? But A and D still have to be congruent to each other because the 2 triangles are similar. B and E are congruent. C and F are congruent. Okay? And the sides, you still have it where the sides are going in the same ratio. So, again, I'm just making up numbers. If this was 3, we double it to be 6. If this was 5, we double it to be 10. If that's 4, we would double it to be 8. Okay? So we still, each side that corresponds is still going to increase or decrease by the same ratio. This, again, scale factor is essentially what it is, dilation. Okay? So let's look here. Okay? Which statement is false? AB over BC is equal to DE over EF. Well, again, our letters to our sides match up. AB is first, DE is first. To BC and EF. BC is the second 2 letters, EF is the second 2 letters, okay? If you have it like I just did, you can actually draw it out. I've got AB to BC, so I've got 3 to 6 is equal to DE, or it's AB to BC, I'm sorry. I was doing AB to D. So AB to BC, so I've got 3 to 5 is equal to DE over EF, 6 to 10. I'm writing it how I had it on the paper. Really, it could just be a fraction, though. Okay? There we go. So those fractions are equal. If you simplify that by a factor of 2, divide that by 2, divide that by 2, obviously it's going to simplify to 3/5. So number 1 is true, okay? AC over DF is equal to BC over EF. AC, first and third letters. DF, first and third letters. Okay, that matches. BC, second and third letters. EF, second and third letters. So hopefully it matches up. Let's look. All right, we got AC, which is 4, over DF, which is 8. So this is what I was trying to do earlier, but with the other ones. All right, so 4 over 8, or 4 to 8 equals BC to EF. BC is 5, EF is 10. Okay? Again, here we go. If we actually made those fractions, 4/8 over 5/10, both of those simplify to 1/2, so those are equal. So that is not false, that is true. Angle ACB is congruent to angle DFE. Okay, so ACB, again, we use the 3 letters. C is the middle letter, though, so that is the vertex. Okay, ACB, so that's this angle, is congruent to DFE. DFE. So congruent to that angle, which I know has to be true. Again, on similar figures, the corresponding angles are still congruent. So 3 is true. Let's look at 4. ABC is congruent to EDF. Okay. ABC, again, this should not be true because the first 3 were. So we're saying ABC right there. EDF. EDF. So we're saying those are congruent, which I know is not true because they don't correspond. All right. Either this would have to be up here or this would have to be down here. And the triangles are scaling. So I know these 2 angles are not congruent. So it is answer choice 4 once again. Answer choice D, however you want to say it. All right. Again, I'm trying to race with one hand with a board that's moving around. I need to find some way to stabilize this board while I'm working on it. All right. Let's move to number 10. All right. Got a triangle. AB is congruent to AC. Okay. So I've got 2 sides that are congruent, there and there, which means I have an isosceles triangle. Again, we didn't really talk too much about isosceles triangles this year. I know we mentioned some. I know y'all know what they are. But again, if we remember for isosceles triangle, 2 of the sides are the same, and then the angles that are across from them, so that angle and that angle, are the same. Okay, it tells me B is x plus 20, A is 3x. But I know C also has to be x plus 20. Okay? So, let me write it down. All right, there we go, just a quick sketch. What all the angles of my triangle got to add up to? 180. So add all that, set it equal to 180. You can write it out separate, but I'm just going to combine like terms. 3x, x and x is 5x. 20 and 20 is 40. 5x plus 40 equals 180. Subtract 40 from both sides. 5x equals 140. Divide by 5. X is 28, which is an answer choice. Number 2, answer choice number 2, or B. Okay? Again, if they were actually A, B, C, D. So 1 does not, 3 or 4. All right, number 11. Quadrilateral MNOP is a trapezoid with line segment MN being parallel to line segment OP. If M prime, N prime, O prime, P prime is the image of MNOP after a reflection over the x-axis, which 2 sides of the quadrilateral are parallel? Okay, so again, this is kind of one you just need to draw out. Even if it's something we didn't necessarily look at a specific example, you should be able to draw this enough. Again, you should know what the shape of the trapezoid is, even though we didn't talk about them a lot. Okay. M, N, O, P. All right, so there's my trapezoid. Again, it tells me these are parallel. The same number of arrows on lines mean that they're parallel, right? So we're reflecting over the x-axis, this one. So we're just going to flip this down, right? So it should look something like this, correct? So O would come here, N would come all the way down here, prime, prime. P would come down, or P would be right here either. And then M would be here. So it's flipped, but since we flipped it up and down, those are still the parallel ones to each other. M prime, N prime, O prime, P prime, which is answer choice 1. Okay? All right. And number 12, last one. The sphere is inscribed inside a cube with edges of 6 centimeters. In cubic centimeters, what is the volume of the sphere in terms of pi? So this is a volume question, but again, one we haven't quite seen. So we talked about inscribed shapes a little bit. We mostly talked about inscribed quadrilaterals inside of a circle. So something like that, okay? a sphere is inscribed inside of a cube. So this is how this is going to look. I'm going to try to draw it the best I can. This probably isn't going to look that great, but I'm going to try. Okay. Probably should just pull up a picture on the internet. Let me do that. Hold on. Let me see if I can find that first before I try to draw this, because I'm going to butcher the drawing and it's not going to help. Alright, let me try to find this on the internet. I have a square inscribed inside of a cube. Okay, there we go. So the basic idea of it is this, okay? Again, it's kind of hard to see here, but when it says it's inscribed inside of the cube, basically what that means is the top of the sphere is in the very middle of the top face of the cube, okay? The very bottom of the sphere is meets the bottom face of the very middle, okay? The front side meets it right here, the back side meets it there, this side meets over here, same with that. So a sphere inscribed inside of a cube touches the cube in 6 spots in the middle of each face. So there, and the other 3 sides as well, okay? Well, how is that going to help me? Well, again, if you think about it, if it's the very top of the ball touching the top of the cube and the very bottom of the ball touching the bottom, all right, that's the height, right? Top to bottom. That's the height of the sphere, or of the cube rather, but it's also the diameter of the sphere, going all the way through the sphere. So the height and the diameter are going to be the same. So we come back, okay? Tells me the cube has edges of 6 centimeters. All right, so again, I don't have my sphere in here. Well, let me try to draw something like that. It's not going to look great, but I'm just going to have to trust me with it. All right, so 6, 6, and 6, right? The height being 6 is the key, because if the height is 6 here, again, it's also 6 right here, which happens to be the diameter of the sphere. And diameter isn't going to help me getting the volume from the sphere. What is going to help me? The radius, right? And if I know the diameter, I just divide it by 2 to get the radius. So I've got a radius of 3. So I'm just going to plug that in, and I'm going to get the volume. And it says in terms of pi. So this is how we're going to do it, okay? So I'm going to have 4/3 pi 3 cubed. Okay, so this is what I'm going to do, okay? I'm going to have pi over here separate because I want it in terms of pi. So I actually don't want to multiply by pi. But I'm still going to do the rest of this math. So I'm going to do 4 times 3 cubed divided by 3. You can punch this part in your calculator, okay? But if you really think about it, okay, 3 cubed divided by 3. Again, if you're doing order of operations, technically you would multiply that first and then divide. But 3 cubed, if I have 3 3s and take 1 out, that leaves me with 2 3s, right? So it's really 4 times 3 squared, which is 4 times 9, which is 36. Okay? If you want to go ahead and punch that in your calculator, that's fine. I'll still show you that you get the same thing, though. Okay, so I've got 4 times 3 to the 3rd power equals 108 divided by 3. Still got 36, okay? So this whole thing gives me 36. So I've got 36 times pi. Oops, 36 times pi, which I can just write as 36 pi, which is answer choice 2. All right, so there we go for today's problems. Again, I'm recording this about, ending this a little after 4 o'clock. I will start to upload it about 9 o'clock tonight. Hopefully it won't take too long. A couple of my uploads have been taking a little while here. And I'll be back tomorrow with the next page. So until then, y'all keep sending me questions if you got them. Otherwise, y'all take it easy, and I'll see y'all tomorrow.